Portrait to Landscape, Chapter 2, The Current Landscape, Global Warming. The Earth has already experienced a warming of 1.1 degrees Celsius, 2 degrees Fahrenheit, above pre-industrial levels as of 2021, and this seemingly small increase has led to devastating consequences, such as prolonged droughts, extreme heat waves, and severe floods. The goal of the 2015 Paris Climate Accord was to limit global warming to 1.5 degrees Celsius, 2.7 degrees Fahrenheit. But at the current rate of acceleration, we are projected to reach this threshold by around 2040. However, even if we manage to meet this ambitious target, the impacts will still be significant, including the disappearance of significant loss of glaciers worldwide, increased water scarcity for millions of people, and a substantial risk of species extinction. The world is currently warming at an unprecedented rate, primarily due to the burning of fossil fuels in various sectors such as transportation, food and energy production, and industrial activities. These activities release greenhouse gas emissions, including carbon dioxide, methane, nitrous oxide, water vapor, and synthetic fluorinated gases, which accumulate in the atmosphere and trap heat from the sun and Earth's surface. Normally, this heat would escape into space, but the presence of these long-lasting greenhouse gases causes the planet's temperature to rise, leading to the greenhouse effect. To address global warming, a committed and integrated strategy encompassing both mitigation and adaptation measures is essential for long-term solutions. It may be hard to comprehend how a relatively small temperature increase of 1.1 degrees Celsius, 2 degrees Fahrenheit, can have such a profound impact. But if we consider the human body, we can understand its significance. We all know how unwell we feel when our body temperature deviates from the normal range of around 37 degrees Celsius, 98.6 degrees Fahrenheit. A slight increase in temperature results in fever, signaling that something is amiss and we are in danger. Temperature fluctuations, whether too high or too low, can disrupt the delicate balance of our bodies and quickly lead to severe illness or even death if left untreated. Similarly, the health of our planet and its natural systems is intricately connected. When the Earth's temperature rises significantly, it experiences a kind of fever, and life suffers as a consequence. Moreover, we humans have played a significant role in pushing the Earth into a state of ill health. A concoction of poisons is incessantly spewed into the air, dumped into the soils, and spread in our waters, weakening the Earth's stability. Polar ice caps continue to melt. Flood levels rise. Hurricanes become stronger and more intense. Droughts and heat waves become more frequent and extreme. Wildfire season is extended, and precipitation patterns become unpredictable. The Earth has not been given a chance to heal as harmful substances continue to be emitted or produced through many industrial and technological processes. While the planet feels the detrimental effects of these substances, and the catastrophic consequences are evident all around us, we persist in the same destructive behaviors. Breaking free from economically profitable but harmful practices without clear alternatives is undoubtedly challenging. A global effort to rehabilitate the planet and adopt life-saving behaviors is urgently needed. Society must immediately abandon addiction to harmful substances and embrace a new way of living. The world must take immediate action to address climate change. We must demand government legislation to control major polluters and enforce substantial reductions in emissions, particularly carbon dioxide. Additionally, we can urge our governments to modify their investment approach by redirecting budgets and financial subsidies toward more sustainable forms of transportation, energy, food production systems, industry, and manufacturing. Fortunately, countries worldwide have made formal commitments to reduce emissions by setting new standards and implementing policies to meet or surpass these standards. However, the not so good news is that progress is not happening fast enough, and many nations are falling short of their commitments. To avert the worst impacts of climate change, scientists emphasize the need to reduce global carbon emissions by as much as 40% by 2030 and achieve net zero by 2050. While reducing emissions is crucial, it is only one aspect of tackling climate change. A more promising and powerful solution lies in the radical transformation of vast landscapes worldwide. Carbon sinks. Nature provides us with a constellation of beneficial processes and systems that support life and regulate the planet. Part 3 of this book explores the attributes of landscapes that are freely provided by nature, often overlooked and taken for granted. In today's world driven by economics and consumerism, these gifts of nature are primarily viewed in terms of their value and usefulness to humans, referred to as ecosystem services. These services encompass various benefits such as food provision, fresh water, natural medicines, recreational opportunities, tourism, and inspiration. Nature services also include vital functions like supporting healthy soils, decomposition, pollination, and regulatory effects that cleanse the air, manage floods, purify water, and sequester carbon. These absorptive landscapes are often referred to as carbon sinks. Forests, soils, and oceans are the most significant carbon sinks, exerting a particularly effective regulatory influence on global temperatures. Their capacity to sequester vast amounts of carbon is truly remarkable. However, these carbon sinks face threats from human activities that alter land and sea use. Soils, in particular, are unsung heroes in carbon capture, absorbing approximately a quarter of all carbon emissions each year and storing it underground for thousands of years, while supporting a diverse population of microorganisms. Unfortunately, the widespread disruption of grasslands and forests, primarily for agricultural expansion, has the opposite effect, releasing carbon from the topsoil back into the atmosphere. Global forests absorb roughly 2.6 billion tons of carbon dioxide annually, with the Amazon rainforest alone capturing a quarter of that total. However, forests are lost at an alarming rate of 1 football pitch every second, jeopardizing any progress in tackling climate change, and in fact adding to the problem, while also threatening the survival of wildlife. Trees are widely recognized for their remarkable ability to capture carbon, but there are other resilient ecosystems with significant carbon capture capabilities as well. Tundra, seagrass meadows, mangrove forests, and salt marshes are particularly effective in capturing carbon per unit area. The concept of blue carbon refers to the carbon captured by ocean ecosystems, which can sequester and store carbon at a faster rate than forests. The ocean is so successful at absorbing carbon dioxide, capturing 90% of excess heat generated by these emissions, that it hid the effects of harmful emissions for many years. Like soil, it absorbs approximately 1/4 of all CO2 and creates half of the oxygen in the atmosphere. These ocean ecosystems serve multiple functions, including coastal habitat protection and food security. However, if these ecosystems are degraded or damaged, a substantial amount of stored carbon is released back into the atmosphere. Unfortunately, warming, acidification, pollution, and other factors threaten the health of the world's oceans. To address global climate change, immediate action is needed to halt further destruction of these invaluable ecosystems and carbon sinks. We must harness the exceptional capacity of forests, soils, and oceans to pull CO2 from the atmosphere. Moreover, we must protect, restore, and care for these landscapes at a historic scale and for the long term. Some practical ways to increase carbon storage include transitioning to sustainable forestry and agriculture, ecosystem restoration, and safeguarding intact wild places. The common thread linking all these effective solutions is their nature-based approach. They are measures that unleash the incredible processes of nature to correct the imbalances in the environment. Part 4 of this book outlines precisely how we can enable nature to accomplish this feat when we collaborate, from governments to environmental organizations to individuals, by making a commitment to radical landscape rehabilitation and transformation. Ecological collapse. Climate change is only part of the world's environmental problems. Many scientists believe that ecological collapse is an even more significant threat. Despite receiving less attention in the news, the decline of biodiversity, erosion of habitats, and extinction of wildlife are occurring at an alarming rate. These impacts may not be readily visible in our urban lives, but the degradation of the natural world is unfolding in forests, soils, and oceans. Currently, species loss is accelerating with approximately 1 million animal and plant species now under threat. While the Intergovernmental Panel on Climate Change, IPCC, addresses climate change, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, IPBES, provides scientifically credible assessments on biodiversity. Comprised of nearly 140 member governments, the IPBES offers an essential perspective on the current state of biodiversity. Their global assessment of biodiversity and ecosystem services comes at a critical time, as in the last decade there's been a significant increase in understanding biodiversity and ecosystems and their value to the quality of human life. This report is equally alarming as the IPCC's findings on climate change, as it highlights the worldwide deterioration of nature and ecosystems. According to the report, the biosphere upon which humanity as a whole depends is being altered to an unparalleled degree across all spatial scales. Biodiversity, the diversity within species, between species, and of ecosystems, is declining faster than at any time in human history. Intense human landscape alteration and exploitation is the greatest threat to the Earth's biodiversity. The IPBES has identified 5 critical human-induced triggers. They include 1. Changes in land use and sea use. Any change in a species' environment caused by activities such as logging, unsustainable agriculture, infrastructure, mining, deforestation, and urbanization, resulting in habitat loss. 2. Species overexploitation. Directly, when a specific species is targeted for sustenance or trade, for example, commercial fishing. Or indirectly, when a species is killed unintentionally as a byproduct, i.e., catch from unsustainable fishing practices. 3. Invasive species and disease. Native species are disrupted by invasive species that introduce disease, prey on native species, and take up space, food, and other resources. 4. Pollution. Different forms of pollution have various deleterious effects on a species' environment. For instance, an oil spill has a sudden impact, whereas other pollutants, like microplastics, have a more gradual development. 5. Climate change. Triggers irregular seasonal change, which confuses the natural order of phenomena such as migration and reproduction. Threats to biodiversity and wilderness will be discussed in more detail in Chapter 8. The World Wildlife Fund Living Planet Report has similar findings to the IPBES report. Using data from over 4,000 species, they track the number of mammals, birds, fish, reptiles, and amphibians across the globe, and have found that from 1970 until 2016, there has been a dramatic decline globally. Latin America and the Caribbean have seen the most significant reduction of 94%, with Africa at 66%, Asia Pacific at 55%, North America at 20%, and Europe and Central Asia at 18%. Changes in land and sea use make up the largest percentage of the decline, with much of this loss being driven by the massive destruction of the Earth's rainforests, which are especially important for biodiversity and carbon storage. The IPBES has issued a warning, emphasizing that nearly 1/5 of the Earth's surface faces a high risk of plant and animal invasion, particularly in biodiversity hotspots. The movement of invasive alien species is significantly influenced by trade, as the introduction and spread of these species are often connected to the movement of people and goods. The consequences can be severe, with some invasive alien species leading to the decline of native populations on a regional scale. One example of the devastating impact of invasive alien species is the infectious fungal pathogen Batrachochytrium dendrobatitis, which has caused numerous amphibian extinctions. This pathogen has infected over 700 species worldwide, contributing to the decline of amphibian populations. In the realm of agriculture, transboundary pests in the form of invasive alien species can have disastrous effects by decimating crops. Global crop losses of 20 to 30% occur annually due to these pests, posing a significant threat to food security. Scientists warn we may now be well into a sixth mass extinction event. The fifth mass extinction, caused by a massive asteroid impact, ended the age of dinosaurs and obliterated 75% of all species on the planet at that time. In the 65 million years since, the natural world has been rebuilding, only now to be threatened not by an alien invader, but by one of its own and most recent species, Homo sapiens. As part of the natural world, we are also a threat to ourselves. Human life is not a certainty, and our species is not exempt from the danger of extinction. What are we doing about it? At COP15 in 2022, the UN Biodiversity Conference in Montreal, almost 200 countries agreed on goals and targets to halt and reverse biodiversity loss by 2030. The targets include conserving 30% of the world's lands, inland waters, coastal areas, and oceans, restoring 30% of degraded terrestrial, inland waters, and coastal and marine ecosystems, reducing to near zero the loss of areas of high biodiversity importance, cutting food waste in half, raising financial flows for developed countries to deliver $30 billion for developing countries in the same time frame. These commitments are indeed profound and will be transformative if implemented. Chapter 10 considers these developments and the actions required in more detail. The predictions from the IPCC are alarming, indicating that if we continue on our current path, climate change alone may jeopardize the existence of as many as 1 in every 6 species by the year 2100. However, certain vulnerable species, such as pollinators, face an even greater threat. This issue becomes even more urgent when we consider the close connection between climate change and biodiversity decline, as highlighted by the IPBES. If we fail to address both these issues promptly and comprehensively, along with pollution and waste, we risk facing an imminent ecological collapse. It has become evident that simply reducing greenhouse gas emissions will not be sufficient to tackle these global challenges. Fortunately, an equally effective approach lies in the protection and restoration of landscapes as carbon sinks, which can serve to regenerate ecosystems and reverse ecological decline. By adopting an integrated approach that addresses climate change and ecological collapse together, we can achieve synergistic and far-reaching benefits. This approach can be visualized and guided by the Ecosystem Services Wheel, which provides a framework for understanding the interconnectedness and interdependence of various ecosystem services. However, it is important to note that addressing climate change and ecological collapse represents only the initial steps in a much broader and more complex agenda.